Good morning, everybody out there in LinkedIn and YouTube land, at least on the East Coast and the West Coast of the United States. Good evening to anyone who has made the time to join me from other parts of the world, especially India, since tonight or this morning, my guest will be Gosakan Aravamudan. He's an inventor and an entrepreneur, and just so happens to be a colleague from, as we were just discussing, over 20 years ago, when we both were in the telecom and fiber optic deployment space. We were on opposite ends of the business. He was more on the demand side, and I was more on the supply side, and that was an interesting time. But we had an enjoyable run watching the meteoric rise of a startup to a multi-billion-dollar corporation, and of course the catastrophic flameout as all of our paper millionaire shares went to zero, close to zero. Regardless, this is a story about Gosakan, wonderful colleague. We had a wonderful time working together. And he's reinvented himself as well as inventing a new product. And as always, I do these LinkedIn's because I want to introduce interesting people that I have met in the course of my career or also personal life. Everyone has some really interesting stories to tell. And Gosakan is definitely one of those folks. And I started out the year with this mission to do more of these LinkedIn lives, which are also able to be simulcast on YouTube. You'll always be able to find these episodes on LinkedIn. But secret pro tip is that it's easier to find them on my Tricky Water channel on YouTube. They're all nicely cataloged there, and you can watch some of the older ones, even some of my test ones from last year, and also the ones I've done this year. We've got another exciting guest next week. But without further ado, I'm going to bring Gosakan on in a second. But before I do that, I just wanted to share something that he sent me. It's not going to be very clear to you what it's about, but he'll explain things to you as we go through our discussion. And I'll play it again at the end, but this is just a teaser of what we're going to talk about. So the only thing you got out of there is that his company is called Pinterra. I don't want to steal any of his thunder and say any more about it. It's just a really cool video, and it'll make a lot more sense to you after he talks to us all. So let's bring Gosakan onto the stage. Hey, Gosak, how are you? Good evening.
Good evening. It's so nice to be here and see and experience people all over the planet signing in from different places. So it's just awesome.
Yeah.
Nice,
Well,
nice to be here.
what's funny is I was in India last week, as you're aware, and I couldn't find a second to call you while we were in the same time zone. But somehow we've managed to connect many hours apart to have this discussion. So I'm really excited, looking forward to it. But Gosakan, I told people that you and I have known each other for over 2 decades, so that means we're very old. But with that said, that also brings some experience, right? And so what I want to do is just turn it over to you. Share a little bit about yourself with people who may not know you, and then slowly dive into the core of what you do today.
Brilliant. Okay, thanks, Manish, so much for giving me the opportunity. It's just um, this is a really interesting topic. This is actually quite going to be less about me and more as the experience of inventors, the problems that we are facing today in agriculture, and what people are trying to do, and what people like me are trying to do, right? So it's a lot of action going on, a lot of excitement. The problems are really big, and so that's pretty much it. What I'm going to talk about today. Um, So let me, as a very quick introduction, my first work experience was in conning, where I interacted. I was a product analyst. I interacted with people who invented the different types of optical fiber. Like I said, this is more about inventors and their approach. That particular company, Conning, probably established about 100 years ago, probably. They started off with glass sciences, and they're one of the few companies who stuck on to a fundamental core discipline, and using that technology, searched out for applications, are now a market leaders in so many things. So that's something inventors there are. It's more for technology looking for a solution. It's one of the rare firms like Applied Materials in New Jersey, Manish, you remember? So these kind of companies are very rare and very few. Okay, and for the rest of the world, you have the inventors, right? The individual inventors, who are, interestingly, I have interacted probably with about a 500 inventors over my career. In fact, at one point in time, I was filing patents for people. So it was just remarkable, people's perspective on trying to solve problems, right? So so after, anyway, I was digressing a little bit, but after working for Corning, I had a chance to work along with Manish and JDS Uniphase, meteoric rise of fiber optics, and meteoric fall also. So the joke was this: we were so good at what we did. We deployed so much fiber. We got so much information going. Nobody needed us afterwards. so so we basically shot the whole industry shot itself in the foot by just being too efficient. So that's that.
Yeah,
So
I mean, we definitely saw the implementation from the inside. Everything from large scale, submarine projects, fiber going transatlantic, all the way to fiber to the home. And once it got to the home, like you said, they didn't need us anymore.
exactly. But interestingly, there are a few points that we learned in these things, and especially in some industries like this, is reliability, product reliability. So I was a product manager of a fiber optic transceiver, and once you put that down in the ocean bed, if you want to fix it, it's $1 million expense to fix $1,000 piece of equipment. So reliability is key, and that really was imprinted onto me, Manish, and a whole lot of different people, right? So having said that, so post that, I've always been passionate about nature. And one particular problem, I'm just getting down to the specific right now, is in agriculture. I wanted to solve this problem of reduction in the use of land, right? Agriculture affects land use significantly. In fact, that is the number one cause of deforestation. I'm very passionate about that one particular aspect, right? So I was wondering, how do we solve this? So and I came up with the different concepts in my journey. Some of them are totally crazy in the beginning. One was, I actually made foamed ceramic panels 2 inches thick as a substitute for wood. Okay, so we had this massive furnace which was used to make foam ceramic panels, and then followed by another invention where I made the thinnest stone quartz sheet. You could actually flex the stone quartz sheet. I have patents granted on that. And then carbon fiber composites, extremely lightweight composites, and glass fiber composites. Now, all these things, I'm not sure whether they help me, but in my current avatar, right, where I'm trying to solve this problem of reduction in land for agriculture. So the definition of the problem is really simple: is how can you have an order of magnitude improvement in yield? Now, in agriculture, usually the improvement in yield, even by genetic modification and a lot of other things, if you were to achieve 10 to 30%, it's just great, right? So that's like the gold standard. Now, coming from engineering discipline, the Moore's law and everything else, always factors of 10. So I said, okay, how do you fix a factor of 10, like an engineering problem to this? And we have come up with a solution where on one metric, that is the yield per square foot of growing surface ground, we have hit that metric of 10x more than comparable solutions, right? So again, the whole solution is about how you reduce land and how you're able to do this. So in my backdrop, you have here probably one of the world's highest density vertical plant growing systems. This is about 8 to 9 feet. This is an interior system. Okay, so now we also have an exterior system. The video which was played right at the start, I just love that clip. That's the exterior system. So I see this thing running here saying, if you have any questions, just place it in the chat. So feel free to interrupt me anytime at all, the audience.
Sure.
So
And one thing I did want to mention is, of course, in the video and what is in back of you is essentially something that everyone is a little familiar with, which is vertical farms, right?
Mhm.
But you've again taken vertical farming, which was trying to give us, I guess, year-round access to agriculture, but it was still not at the level of efficiency that I guess we as a society need now.
Exactly. Yeah. So the thing is, vertical farming has its challenges. Okay. And there were three biggest challenges in vertical farms, right? Now, when I say vertical farm, whether it's indoor or outdoor, okay, whether it's with LED lights or without LED lights in greenhouses. So when we're talking about controlled environment agriculture, which sort of encompasses both the indoor and the outdoor systems, and fundamentally, anything which needs to be efficient has to go on a vertical plane. Even in sunlit systems, because when you have sunlight, right, you have say 100,000 lux. The plants only need about 30 to 40,000 lux. So how do you channel the rest of the 60,000 lux onto other plants, right? So you can actually use vertical systems even in fields using greenhouses, right? So that's where I attack the problem with my external system. So we have, yeah. I mean, I'm sort of. Go ahead, Manish.
Yeah, no, I mean, I think what you had mentioned to me the other day, which I didn't know in our previous conversations, I found very interesting, is you got into the very specifics of how your system specifically is improving yield and use of square footage. And please, feel free to get into some of those details because I think those are the things that make what you've done interesting. And then, of course, we can return to the subject of invention as well. And I know we have some slides. Whenever you want to share those, we can share those as well.
Yeah. So I think probably this is a good time to just share those slides quickly, so it gives
Okay,
context. Yeah.
sure. Let me just hide something here so we can see them better when they come on. There we go. There we are. So you just let me know when we want to move ahead, but go
Mhm.
ahead, Gosak.
Yeah. Yeah. So these are the most painful problems of today. I know you've seen these problems being highlighted everywhere, but I can't y- downplay the significance of these problems. Okay. The first is water. We simply don't have water. Okay. uh, when I speak, I don't speak from a western perspective, but I also speak from a perspective from the east, the challenges we face there, right? Simply fresh water is a challenge everywhere, even in the tropic areas, where there's a lot of rainfall. So there's a and the problem with agriculture today is when the government gives you free electricity and you just pump out the water and you're growing crops in areas which shouldn't be grown in those areas, you have massive issues with water usage, right? So so that is one huge problem that we've solved. And the next slide, I will explain to you how we've solved that problem. The
So
second
before
is,
we get to the next slide, we just have a question from Prasan Patil. Are the internal vertical farm temperatures controlled? Very
oh
simple,
yes,
probably.
oh yeah. So Prasan, that's the biggest thing. You just nailed it. See, temperature control, right? There are two factors, actually three factors in plant growth, right? One is temperature control, right? And in that, we come up with a very unique solution, right? So we have access to the root zone cavity as well as the leaf zone cavity. There are two areas where we actually have access to. When I say access, we can actually funnel in fresh air and air with different temperatures and humidities. So what we've done is, exemplarily, for example, the first video clip that you saw, the root zone temperature today in our plant growing system out in the outdoor greenhouse, the root zone temperature is 23 degrees. Okay, whereas in the afternoon, the leaf temperature, the area above the leaf, okay, was 36 degrees. Okay, and the leaf temperature is 28 degrees, right? So our goal is to maintain the root temperature at 24 and the leaf temperature around 26, right? Even if the ambient outside temperature is really high, right? Now you may be wondering, why am I just blabbering about the temperature, right? Because temperature is everything. If you're able to, if you don't need to bring down the temperature in the tropics, now I'm specifically talking about the tropics. In the east, it's the reverse, where you're trying to heat up the system, right? So we have a patent on airflow techniques where through use of very low energy fans, we're able to funnel air and evaporatively cool the roots, right? So that's a patent that we have filed on, and we are that's really giving us a lot of benefits in plant growth. You wouldn't believe it. For plant growth, if you're able to control the root zone temperature, you have more oxygen being fed to the roots. If you have more oxygen being fed to the roots, it's able to metabolize and push in the nutrients faster into the leaves. It helps, and once you have good transpiration, the plants grow really well. So
So
anyway, long answer. That's a problem when I
yeah,
ask.
no, but you threw a couple of words in there that are not just specific to your technology or your product, um, oxygen, right? But also what you have highlighted on this slide and the prior slide in terms of challenges, and then here you have kind of like what the benefits are of what you're doing. But water, energy, land, and then of course expenditure, right?
Yeah,
Because for people to do or implement your system, it also ultimately, we when we want to do good, right, for our planet or for each other, we typically, by human nature, also want to do well, right? Even a nonprofit has to remain cash flow positive. So, the point is that you're addressing macro issues here. Some of these issues actually I touched on in the previous three episodes with my guest about water and capitalism, but efficient capitalism called degrowth, all related to climate action, and of course land. And you're living in a place that in a country that has a lot of people, a lot of growth, and a lot of growing needs. And so food and agriculture are under a tremendous amount of pressure, right? And so if you go through this slide, you could kind of tell us like what your ambitions are for not just the world, but starting with India.
absolutely. In fact, some of the problems that I'm trying to solve, maybe some of them might be local, but the applications are fundamentally global, right? And there have been many global players who appreciated the hard work we're trying to do. Okay. So, for example, let me take land, right? So, in many parts of the world, we have a very hilarious, unique problem, right? So, you have land being inherited, right? Generation to generation. So, you start off with 50 acres, the next time you have a big family, you have 5 kids, it goes into 10 acres each, and then it gets split exponentially. So, right now, the situation is in a village, if you go, if one person has a couple of acres of land, that's huge. Now, that's not the case in the United States. That's a different issue, right? They have big land holdings. But in many other parts of the world, this is an issue. So I had to create a solution where, with a small land holding, you can have an extremely powerful business. So that's the definition of my problem, is with 1 or 2 acres of land, how can you multiply the profitability? I'm not talking about revenue, just fundamentally, you should be 10 times more profitable to actually sustain yourself as a business, whether it's a farming business or related agri business. Now in India, you have about 60 to 70% of the people in the farming sector, so it's a big thing here, right? So the thing is this: if you have so less land, so I have created a solution which is about anywhere between 5 to 10 times the yield of a relatively conventional flatbed hydroponic system, right? And compared to land, it's about 15 to 20 times greater in yield, right? So now where do these numbers come from, right? So this is what I'd like to explain to you. So now I really researched the plant growth. We actually spent 6 months on this, just understanding how, from seed to the the final harvest point, what are the factors which influence plant growth. And interestingly, we found out that the plant growth is asymptotic, right? It starts off flat as a seed, and then, for example, in a regular farm, you would, in a square feet, you would have to put in one seed, or even in an indoor hydroponic system, in 1 square feet area, you have to put a seed there. You have to leave space around for the plant to grow, right? So I looked at that problem and I said, how do you get rid of all that space? So what we did was we created the world's first, a patent pending expansive membrane. So you just drop the seeds, and at the time of dropping the seeds are literally touching each other, right? So the area is so well compressed. And now as the seed germinates and as the first true leaves comes, and the plant slowly starts growing asymptotically, the space allocated is really shrunk, right? So, and in the final week of plant growth, the spacing increases. So what we're able to do is, by a factor of 2.5x, almost 250% more efficiency in space in the x direction, right? And then we have another interesting thing is, like I told you, in a greenhouse, you have 100,000 lux, right? The plant only needs 35 to 40. So I took the 60,000 lux, the rest of it, and then using diffused sheeting, you're able to get it down on a vertical A-frame at an angle of, say, 30 degrees. And so I'm able to multiply that area by 2, so on a vertical plane. So you have that by 2, and then on a horizontal X plane, we have the expansive membrane sheet, which gives us a 2.5x difference, right? So you multiply that, it's 5x in yield just by space optimization. So go ahead here.
Yeah, and so all of this that you're talking about, right? Agriculture. What I didn't want to miss out on is, of course, I want to get to the discussion of of the path to invention. But when you decided to go down this path, right, knowing what your career has been about, it wasn't by accident. If you don't mind sharing a little bit about that personal connection to agriculture, I think people will be able to make sense of, like, how did this guy get into this?
Yeah. So the funny thing is, when I grew up, right, uh, I never actually met my grandfather, my father's father, but he had written this amazing book on complete gardening in India, right? Even now, that's the gold standard on how we want to grow, graft roses and things like that. So we had these amazing books on that, and for some odd reason, I just got hooked onto it. And I happened to study in an academic campus and live there, so I naturally got into engineering. I mean, I didn't know there was anything else existing. So, but so once you get hooked onto plants, it's like there's no end to it. So it's always in the back of your mind, and it's only a question of time before you just fall back into that. So I always had a passion for growing plants, and that I never realized would turn into something like what we have here. So the transition was extremely difficult because professionally, right? How the whole thing is about how do you define a problem worth solving, right? So that was the problem, is how do you define the problem. It took me many years to figure out how to define the problem. I'm a materials scientist, so I've invented many materials. So using I was trying to force fit, like, what my skill set was onto the passionate problem I'm trying to solve in agriculture and land use. But that doesn't work, right? That's like thinking bass backwards. The tail doesn't wag the dog. So what I figured out was that, hey, you got to look at it as it is. It's a problem. It's a huge problem. And just go at it. So I just defined the problems as, three problems. One is temperature control, one is land use, and the other is energy optimization. And they're all fundamentally engineering problems. So anyway, that's a long way. And using my engineering skills, we created a solution for both indoor and outdoor systems that you're viewing right now. And it's really
Well, I mean,
exactly, yeah. Go
you're
ahead.
one of my favorite type of inventors because it's an invention that I can actually sort of understand, and I can certainly, feel the benefits of it when it reaches market. So, at what point you have this idea, right? I'm going to jump into the invention side of this discussion. At
Mhm.
what point do you decide that this is something worth patenting? This is an invention that can be
Yeah,
patented.
that is actually, Manish, I still don't have the answer to that question. That's the most difficult question an inventor faces. And I'll tell you why, right? Because you come up with a crazy idea, right? And there are a lot of people coming up with crazy ideas at the same time. Now, it's first to file, unfortunately, the rule in most countries. So if you don't file it, you lost it. So the thing is, um, I actually file a lot of patents. I have filed about 80 patents. I got quite a few granted. I'm not saying every one of them has been commercialized, right? But you have to go through the process because you don't know which one is the gem among all of them. And when you commercialize these things, you typically take about 2 to 3 years to figure out which one is actually going to make an impact on society. But thankfully, as far as Pinterra is concerned, all the patents that we filed are all related, and they are very customer folk. They are solving real world customer problems. Okay, so I really believe that literally all of them are going to be extremely useful. And so the short answer to your question is, we file the patents as soon as we realize that it has potential.
Okay. And so the other thing is, what are the challenges? Because one of my good friends and clients, she got a patent last year after a pretty long and challenging journey. Unlike you, this was her first time delving into the invention space, and she learned a lot of lessons that I think she's going to be able to pass on to other people. What are some of the and it can be discouraging too. At some point, you decide like, oh, it's not worth it because, especially in the U.S., as you know, it's quite expensive to file a patent,
Mhm.
and to go through iterations in the process is very challenging and frustrating. So, what kept you? Uh, Positive and moving forward through that process, because it never happens the first time out of the gate. At least I've never seen it.
No, see, the patent protection and is really key, especially if you're a product firm. If you're a services firm, that's a different game. But in products, right, especially in the things that we're trying to do, I'll give you an example of the costs involved. Right, a simple patent portfolio of about 3 to 4 patents, and if you're going to take them international, okay, uh, in the major areas, that's going to cost you tops $150,000 over a few years. Okay, so if you're going to if you need to protect all your ideas, it is going to cost you money. So you had to be fundamentally well funded, at least in the first few years as a product firm. So the one way to get around it is say that, hey, I will just focus on one key patent, but unfortunately, you get stuck with the patent portfolio, right? Like, for example, even in our product, I have to control the root zone temperature, I have to control the humidity, the airflow, the light, and so we work hard on protecting literally every one of those parameters with patents, right? So it is very challenging for entrepreneurs. I think that is the biggest thing, and in fact, that's one of the reasons where a lot of people go in for funding to foot those patent costs.
Let me ask you this question too. I'll always go back to the example of the Coca-Cola recipe, right? Um, which famously is, I guess they say, not known by anybody.
But
Uh,
everybody knows
Everybody
it.
knows it. Everybody tastes it, but it's not. There's no patent protecting it. And so
Mhm.
the question I have is one of the, and this is advice, of course, that attorneys have shared with me or other entrepreneurs. Like, hey, the perils of a patent are that, especially in our very flat world, right? Global economy, people get access to your idea, and in countries where you don't have a patent, or even in a country that you do have a patent, someone might decide to copy it. And at that point, are you willing to defend it? And are you willing to spend the money, right? You said $150,000 for a portfolio of about 4 patents. So just multiply that by probably 10x, or let's say 5x or 10x to defend it. So how does that process work? What are your thoughts on the idea of, do you patent everything?
Yeah. So the thing is this, it is actually, even in today's world, it's kind of silly to infringe on somebody's patent. Okay. Because, for example, uh, in our technology, right, it is extremely complex technology. So if someone were to actually take the work hard at copying the same system and making it work, it's going to take them some time. And then the funny thing about the patent system is that if you send them a legal notice telling that, hey, just stop doing what you're doing, and if they continue to do it, and then you just wait till they make money, and then you continue to sue them, right? The process might not get you on day one, but you'll eventually get them. And the way the patent laws are worldwide is that they have to give you the profits they made from the first day they started working on it, they infringed. So it's down. Usually these kind of patent violations happens in easy to copy products, right? And which doesn't take much effort, and you can quickly get in and quickly get out. So those are the kinds of things, the violations happen very rarely in sophisticated technology, because the person who's protected and who spent 150 $200,000 on the patent is going to come after you, because it's just not worth it. It's just really not worth infringing patent portfolios which are well protected.
Well,
you
that was
know
an
and,
interesting little piece of advice there. At the very least, even if you're a small entrepreneur with a patent,
and
a cease and desist might be at least worth a shot before
it
you
works.
go down a
It
deeper
works.
path. Because, like you said, a lot of effort and energy goes into not just filing for a patent, but also being granted that patent. It's quite a celebratory moment, no matter how many patents someone has. And so to have it infringed upon is, of course, it's very hurtful. Could be damaging, of course, as well. So
Mhm.
and also, who knows, the way liability works too is someone else sees like, oh, that, if something goes wrong with something someone copied that you invented, that could be, held against you in some world, right? That's just the
Exactly.
kind of challenges we face in the business world. So, um, but in terms of the path of invention, I wanted to kind of quickly just circle back to something you said, which is, you're an engineer. You worked at engineering, science, and materials firms. And so those are the things you kind of understood at their core, and trying to apply those to this was, square peg, round hole type of thing. How did you ultimately get past that? Because I want to let everyone know that if you have an idea, right? don't be discouraged by the fact that maybe you're not an expert or educated in that field that idea might be relevant to. And in this particular case, while you had this family connection to agriculture, it certainly was not your academic
Yeah.
upbringing that brought you here. So how did you get past that to
Yeah,
get to
I
that
really think of,
what you want?
see, this is just an observation that I've made. I've seen a lot of people, including my own experience, and I've seen a lot of inventors, right? So let me tell you how they approach the problem, or how we approach the problem in general, is that we are self-agnostic, right? It has nothing to do with us. You have a problem, right? So you abstract the problem, and whatever the problem needs to, I mean, if it needs botany, go on figure, go learn botany. If it needs chemistry, learn chemistry. The beauty of today is that we have access to information. We never had that 20 years ago, Manish. We never had access to Google Scholar online, where I had to go to a university, right? 20 years ago, you couldn't search a patent database. You had to go to the physical file wrapper in Washington, D.C., okay, to actually look at the patents. So now you have information at your fingertips. So you can actually define problems, and you can be a self-agnostic, technology agnostic, and attack it individually. And there are people doing this, right? So all you have to do is just define the problem as narrowly as possible. So, and I've seen people do it, and it's irrelevant on what their skill sets are. It has nothing to do with them. It's what they believe they're trying to solve, and I've seen a lot of people do this very successfully, right? In fact, if you're not from the industry, okay, and I'll give you an example. There's a guy in my factory, okay, who's a much better problem solver than I am for a lot of the engineering solutions, right? If something were to happen, right, I'll give you one example, right? There was a carbon fiber stuck at one point, right? And I couldn't troubleshoot it because me as an engineer is thinking, oh, there's something wrong. There's some adhesive here and it's getting stuck. Adhesive and this and that. This guy comes up and says, 2 days ago it rained, right? The humidity went up, the rollers got sticky, right? And the guy was grinding yesterday. That dust settled on the roller. It got more sticky. So when the spool ran, it actually grabbed one among some 10,000 fibers and then spool it up, and the whole thing got locked, right? So now that's pure observation. The guy is a genius, right? So what I mean, the long story is this: is that you don't need a formal education to solve a lot of the problems that we're facing today, right?
That's again, that's a message that I think can be encouraging to a lot of people who maybe have an idea and aspire to invent. So we're coming up close to a point where we could close here. But what I wanted to get from you is, what are the ambitions you have? What is your roadmap? If you could quickly tell us for Pinterra. What are the future plans? What should we, if we follow you, what should we look out for in the future for Pinterra for you?
Brilliant. So for Pinterra, goal is to reduce the pressure on land, right, and make agriculture as high yielding as possible. So the goal is to, right now, 10x. I want to bring it to 20x. So we make our end customers profitable, right? The biggest problem for agriculture today is the end customer sometimes is not profitable. So we are trying to create equipment which makes our end customer win, right? So, and my request to a lot of the entrepreneurs today is, solve there are so many real world problems today. And feel free to contact me. I would define a whole lot of them worth solving. So my hands are full, and would love to share some of those problems with others too.
Thank you. And so, Gosakan, thanks a lot for sharing your story about Pinterra, some of the scientific and engineering details as well. We learned a lot about why this works and why it is something that you actually pursued all the way through multiple patents as well. It's that important. And again, it's going to be something that hopefully you do well with. And then also, of course, do good. Not just for India, but I know you're also going to be sharing this already with folks in Europe who are also at the forefront and understand the challenges of land, water, agriculture, and how it all comes together. And to everybody, thank you so much for joining. As usual, I typically schedule these for about 30 minutes, but the good news is because I'm a solo studio, I get to do whatever I want. Please check out other of these episodes on my YouTube channel at trickywater.com. Actually, at trickywater on YouTube. And you can also find them on LinkedIn too. Feel free to email me at manish@trickywater.com. We can talk about this episode here. Perhaps you're interested in being a guest on a future episode, because like I said, the benefit of LinkedIn should be the ability to share my network and share the knowledge my network has. And hopefully someday Gosakan gets his invention to a scale where we can have that little farm in the back of our own home so we can grow vegetables here. I know I don't have a green thumb, but I have a feeling something that improves yield by 90% can probably even make me a gardener. So again, thank you everyone for joining. Thank you, Gosakan. Have a great evening. Everyone else here on the East Coast or probably early on the West Coast of the U.S., have a great rest of the day. And we'll talk next week, where I have a really interesting guest too, Anthony D'Onofrio. He is bringing an extensive background in private equity and family shops, something that I guess you and I will all learn about at the same time. And also the next step to invention and product is also taking a company public. So he's going to talk about his personal story there. I'm fortunate to know him. I'm fortunate to know people like Gosakan, wealth of knowledge on a variety of subjects. So see you again next week. Just check out LinkedIn for the schedule. It'll be 2 p.m. next Wednesday. Thanks a lot, Gosakan. See you later.
Bye.